Structural engineers analyze, design, plan, and research structural components and structural systems to achieve design goals and ensure the safety and comfort of users or occupants. Their work takes account mainly of safety, technical, economic and environmental concerns, but they may also consider aesthetic and social factors. Structural engineering is usually considered a specialty discipline within civil engineering, but it can also be studied in its own right. In the United States, most practicing structural engineers are currently licensed as civil engineers, but the situation varies from state to state. In the United Kingdom, most structural engineers in the building industry are members of the Institution of Structural Engineers rather than the Institution of Civil Engineers. Typical structures designed by a structural engineer include buildings, towers, stadia and bridges. Other structures such as oil rigs, space satellites, aircraft and ships may also be designed by a structural engineer. Most structural engineers are employed in the construction industry, however there are also structural engineers in the aerospace, automobile and shipbuilding industries. In the construction industry, they work closely with architects, civil engineers, mechanical engineers, electrical engineers, quantity surveyors, and construction managers. Structural engineers ensure that buildings and bridges are built to be strong enough and stable enough to resist all appropriate structural loads, earth pressure, temperature, and traffic, in order to prevent or reduce loss of life or injury. They also design structures to be stiff enough to not deflect or vibrate beyond acceptable limits. Human comfort is an issue that is regularly considered in the limits. Fatigue is also an important consideration for bridges and for aircraft design or for other structures which experience a large number of stress cycles over their lifetimes. Consideration is also given to durability of materials against possible deterioration which may impair performance over the design lifetime. Education. The education of structural engineers is usually through a civil engineering bachelor's degree, and often a master's degree specializing in structural engineering. The fundamental core subjects for structural engineering are strength of materials or solid mechanics, structural analysis, static and dynamic, material science and numerical analysis. Reinforced concrete, composite structure, timber, masonry and structural steel designs are the general structural design courses that will be introduced in the next level of the education of structural engineering. The structural analysis courses, which include structural mechanics, structural dynamics and structural failure analysis, are designed to build up the fundamental analysis skills and theories for structural engineering students. At the senior year level or in graduate programs, pre-stressed concrete design, space frame design for building and aircraft, bridge engineering, civil and aerospace structure rehabilitation and other advanced structural engineering specializations are usually introduced. Recently in the United States, there have been discussions in the structural engineering community about the knowledge base of structural engineering graduates. Some have called for a master's degree to be the minimum standard for professional licensing as a civil engineer. There are separate structural engineering undergraduate degrees at the University of California, San Diego and at the University of Architecture, Civil Engineering and Geodesy, Sofia, Bulgaria. Many students who later become structural engineers major in civil, mechanical, or aerospace engineering degree programs, with emphasis in structural engineering. Architectural engineering programs do offer structural emphases, and are often in combined academic departments with civil engineering. Licensing or chartered status. In the United States, persons practicing structural engineering must be licensed in each state in which they practice. Licensure may usually be obtained by the same qualifications as for a civil engineer, but some states require licensure specifically for structural engineering, with experience specific and non-concurrent with experience claimed for another engineering profession. The qualifications for licensure typically include a specified minimum level of practicing experience, as well as the successful completion of a nationally administered exam, and possibly a state-specific exam. For instance, California requires that candidates pass a national exam, written by the National Council of Examiners for Engineering and Surveying, as well as a state-specific exam which includes a seismic portion and a surveying portion. Most states do not have a separate structural engineering license. In California, Washington, Oregon, Nevada, Illinois and other states, there is an additional license or authority for structural engineering, obtained after the engineer has obtained a civil engineering license and practiced an additional amount of time with a civil engineering license. The scope of what may be designed by a structural engineer but not by a civil engineer without the SE license is very limited. The United Kingdom has one of the oldest professional institutions for structural engineers. Originally founded as the Concrete Institute in 1908, it was renamed the Institution of Structural Engineers in 1922. It now has 22,000 members with branches in 32 countries. The Instructee is one of several UK professional bodies empowered to grant the title of Chartered Engineer. Its members are granted the title of Chartered Structural Engineer. The overall process to become chartered begins after graduation from a UK MEng degree, or a BEng with an MSc degree. To qualify as a Chartered Structural Engineer, a graduate needs to go through 4 years of initial professional development followed by a professional review interview. After passing the interview, the candidate sits an 8-hour professional review examination. The election to chartered membership depends on the examination result. The candidate can register at the Engineering Council UK as a chartered structural engineer once he or she had been elected as a chartered member. Legally, it is not necessary to be a member of the Instructee when working on structures in the UK, however industry practice, insurance and liabilities dictate that an appropriately qualified engineer be responsible for such work. In the United States, application for license exam is allowed 4 years after the candidate graduated from an ABET-accredited university and passing the Fundamentals of Engineering exam, 3 years after receiving a master's degree, or 2 years after receiving a PhD degree. Career and remuneration. A 2010 survey of professionals occupying jobs in the construction industry showed that structural engineers in the UK earn an average wage of £35,009. The salary of structural engineers varies from sector to sector within the construction and built environment industry worldwide, depending on the project. For example, structural engineers working in public sector projects earn on average £37,083 per annum compared to the £43,947 average earned by those in commercial projects. Certain regions also represent higher average salaries, with structural engineers in the Middle East in all sectors, and of every level of experience, earning £45,083, compared to UK and EU countries where the average is £35,164. See also, architects, architectural engineering, building officials, civil engineering, earthquake engineering, International Building Code, list of structural engineers, list of structural engineering companies, structural engineering, structural failure. References: National Council of Structural Engineers Associations, American Society for Civil Engineers. External links: A Day in the Life of a Structural Engineer, IABSE.